Hello, and welcome to this lesson on the historical development of the periodic table. In today's lesson, we will firstly describe the early attempts to classify elements by atomic weights. Secondly, we will explore Mendeleev's significant contributions to the periodic table. Thirdly, we will understand the role of isotopes in refining the periodic table. So far, you've familiarized yourself with the periodic table and the concept of isotopes. You know that the periodic table is a structured arrangement of elements, and isotopes are variants of elements with different numbers of neutrons. Building on this foundation, today's lesson will take us through the fascinating journey of how the periodic table was developed. This lesson will advance our chemical understanding by showing us the historical context and scientific breakthroughs that have shaped modern chemistry, enhancing our appreciation of how scientific knowledge evolves over time. To understand the historical development of the periodic table, we first need to explore how scientists initially attempted to classify elements. Early efforts involved arranging elements by their atomic weights. Imagine early chemists creating lists by lining up elements based on how heavy they were. While this approach seemed logical, it led to incomplete and inconsistent tables because not all elements had yet been discovered. Therefore, some elements, though placed in order by weight, ended up in groups where they didn't quite belong based on their chemical properties. A significant breakthrough came with Dmitri Mendeleev, a Russian chemist who recognized these inconsistencies. Instead of strictly following atomic weights, Mendeleev considered the chemical properties of elements. He noticed recurring patterns when elements were arranged in a particular way. To make his table more functional, Mendeleev left gaps for elements that had not yet been discovered, predicting their properties with remarkable accuracy. For example, Mendeleev proposed that an element he called Eka aluminium would fill one of these gaps. When the element gallium was discovered later, it had properties almost exactly as Mendeleev had predicted, fitting perfectly into his table. This provided strong evidence for the validity of his periodic table. However, there were still some anomalies that did not fit neatly into Mendeleev's arrangement based on atomic weights alone. This puzzle was eventually solved with the discovery of isotopes. Isotopes are variants of elements that have the same number of protons but different numbers of neutrons, which cause different masses. Recognizing isotopes allowed scientists to refine the periodic table by focusing on atomic numbers instead of atomic weights. The shift from atomic weights to atomic numbers marked a crucial advancement. The atomic number represents the number of protons in an atom, providing a more accurate and consistent basis for arranging elements. This brought about the modern periodic table we use today, which aligns elements in a way that reflects both their atomic structure and their chemical properties. Mendeleev's work laid down the foundation for our current periodic table, a vital tool in chemistry that helps predict the behavior of elements and guides researchers in the discovery of new materials and compounds. By understanding the historical development of the periodic table, we can understand it as a powerful framework that links the properties of elements in a way that reveals their underlying atomic structure. Great work! That's everything for today. In today's lesson, we learned how early scientists arranged elements by their weights, which led to incomplete and inconsistent groupings. The major breakthrough came with Dmitri Mendeleev, who organized elements based on their chemical properties rather than just atomic weights. Mendeleev's table included gaps for undiscovered elements, and his predictions for these elements' properties were remarkably accurate. Despite Mendeleev's success, some anomalies persisted due to elements that did not fit neatly when ordered by atomic weights. The discovery of isotopes, which are variants of elements with different numbers of neutrons, explained these anomalies. This led to the shift from using atomic weights to atomic numbers, which represent the number of protons in an atom. This shift provided a more accurate and consistent basis for arranging elements. The modern periodic table, organized by atomic numbers, aligns elements in a way that reflects both their atomic structure and chemical properties. Mendeleev's work laid the foundation for this tool, which is crucial in predicting the behavior of elements and guiding scientific discovery.